Hello everyone. This is, as you can see, the pre-calc assignment for April 27th to 28th. Some of these videos will be getting a little bit longer, and I apologize for that. I'm going to try and keep them as short as possible. The idea that we're starting with is called a limit. And this is where we start calculus. Limits are an essential piece of calculus. Trying to work on the definition of a limit from what you guys know in your day-to-day lives. Think of something like a speed limit. Now, I realize that for most of us, this is more of a recommendation than an actual limit. Your car can certainly go faster than 55 miles an hour, but it's supposed to be a limit. You're not supposed to go faster than it. So let's just play the game. How about you go 5 to 8 miles an hour over? So 60 to 63 is really the limit that you're going to do in a 55. Okay? That's the limit. That is the fastest you should go before you're probably going to get a ticket. A limit is a boundary. It's like a wall that you can't cross. You can't go past that point. It's a physical barrier. Okay? That's a limit. It's a boundary. Okay? So look at this. You got a square. It's 1 foot by 1 foot. So the area of this square would be 1 square foot. So 1 square foot. Okay. Now what I'm going to do is I'm going to take this and cut it in half and set this piece aside. Well, what's the area of that piece? It's a half a square foot. And if I cut this in half and set this piece aside, well, it's half of that one, and that was a half, so this is a quarter. And if I take this and cut it in half and set this piece aside, well, this was a quarter, so that must be an eighth, because this is half of that, so it's an eighth. If I take the remaining piece and cut it in half and set it aside, well, if that was an eighth, this must be a 16th, and I set a 16th aside. And if I take what's left, cut it in half and set it aside, and so on. I keep doing this. Now, if I stop cutting pieces off and setting them aside, my answer is not going to be worth 1. Think of it this way. We know all of this is worth 1 square foot. If I stop cutting pieces out and setting them aside, this is not going to be equal to 1 square foot. But if I did this forever, never stopped, continued to do this forever, what will the answer be? 1. Because the sum of all the pieces need to add up to the whole. Now, this idea of doing an infinite sum should be a little weird. You've always stopped. You've never been able to add up an infinite number of things. What I'm using here is the idea of a limit. What is the maximum number, the sum of all these pieces? If I could keep cutting pieces off and setting them aside, what is the maximum number that's going to reach? 1. Because the sum of the parts has to equal the whole. And this is just giving you an example of what a limit is. This does not get huge. No, it stops growing. It will only be worth 1. Even though I'm always going to be adding something on, the maximum number that's going to be is 1. It's not 0.9 repeating. No, it is 1. It is equal to 1. It's not kind of close to 1. It is equal to 1. Okay? This idea of a limit is something that we're going to start to work on and get our heads around. So here it goes. A limit can be asked in a couple ways. So first off, this is what it looks like. When you read it, the limit as, so I'm going to write it out, the limit as x goes to. This is what this arrow means. That arrow right here is red, goes to. You don't say the limit as x arrow and then something else. No. It's the limit as x goes to. Those are the words that come out of your mouth when you see that arrow. Goes to. And there'll be a number that's going to be written in those spots. Now this is going to seem a little weird at first. You won't know the context with which I'm going to put this, so just hang tight. If this is just a simple number line, I can approach 8 from the left side. I can go, if this is 5, 6, 7, 7.5, 7.9. I'm approaching 8 from the left side. I realize this isn't scaled out. Bear with me, okay? I'm approaching 8 from the left. That's denoted, it's written with a negative sign in the upper right. That's saying you're approaching 8 from the left. If I wanted to approach 8 from the right side, I would put 8 with a positive sign, kind of like an exponent. It's written in the place of where an exponent would go. All right? If I'm approaching -5 from the left, that would be -5 with a negative sign up by the exponent. Okay? If I want to approach it from the right, I would put -5 from the right. And it's a plus sign that's up there. Okay, so here it goes. For this function, whatever this function is, determine the limit as x goes to -1 from the right. So, there's -1. I want to approach it from the right side. So I'm just going to look at my x values, and I'm going to move towards -1 from the right. Your answer is your y value. So as x goes from the right side to -1, your y values are shrinking and then growing back and stopping there. What is the y value at -1 from the right side? 3. So the answer to that question is 3. I know that this has a closed circle and that has an open circle. I'm just going to stick with this one for a second. If I change this to a -1, sorry, from the left, I apologize, I changed it to read from the left, I would be approaching -1 from the left side. As you come at -1 from the left, your y values are growing up to this value. It doesn't matter that at that point it doesn't exist because it's an open circle. What is your y value as you get super duper 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 close to -1? 6. Okay? It doesn't matter that there's a hole, that it's closed here and open there. It doesn't matter. It's as you get closer and closer and closer to the x value of -1, what do your y values get closer and closer to? Okay? So this one, for this function, determine the limit as x goes to 2 from the left. As x goes to 2, so this is the value of 2 right here. There's the value of 2. As you approach 2 from the left, is what that says, your y values are getting bigger and bigger and bigger and bigger and bigger until eventually you get to the value of 5. That's your answer. If I had a plus there and came at it from the right, your y value would be -1. Again, it wouldn't matter that there's an open circle here. It's the limit as you get so close to it, super duper 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 close. What's it worth? -1. It doesn't matter that it's open or closed. Okay? It works the same way. Okay? Most of the questions you're going to bump into have this limit in it. And now and again, they're going to throw in this goofball question like this that just says, find the value at a specific number. It's not asking a limit. It's just asking you to evaluate the function at that number. So I don't want to say everything I told you before this isn't valid. I'm just saying that this is a different type of question because the word limit is not in it. It's just what's the value at 4? So you go to 4 and it's -6 because it's a closed circle. So the answer to this question is -6. If this was open and this was closed, then your answer would just be 3 because it's the y value there. Because the function exists here, it doesn't exist there because it's an open circle. Okay? But as it was written, the value is -6 because that's the y value at 4. So it doesn't involve a limit. Also, you'll start to see this, DNE. DNE just stands for does not exist. all the answers to your questions, I believe, and I could be wrong on this, all the ones that I looked at, you do have an answer, even though they may be providing you the choice of that. I think that's it, because I think this next slide is for the next day. Yep. Thank you, guys. Please come see me in office hours. I miss you guys. Love to see you. And there we go. That's